Hello guys, hope you guys are doing well. Today's topic was OOPS concept, object oriented programming concepts in Python. Object oriented programming is method of structuring a program by bundling related properties and behaviors into individual objects. In this tutorial, you will learn the basic of object oriented programming in Python. Conceptually, objects are like the components of a system. Think of a program as a factory assembly line of sorts. At each step of the assembly line, a system component processes some material, ultimately transforming raw material into a finished product. An object contains data like the raw or pre-processed materials at each step on an assembly line and behavior like the action each assembly line component performs. In this tutorial, you will learn how to create a class, which is like a blueprint for creating an object. Use classes to create new objects. Model systems with class inheritance. Right. What is object-oriented programming in Python? The object-oriented programming in Python paradigm that provides a means of structuring programs so that properties and behaviors are bundled into individual objects. For instance, an object could represent person with properties like a name, age, and address, and behaviors such as walking, talking, breathing, and running. Or it could represent an email with properties like a recipient list, subject, and body, and behaviors like adding attachments and sending. So just focus on this. For instance, an object could represent person with properties, person with properties like name, age, and address. These are the properties. Name, age, and address are the properties. And behaviors are like walking, talking, breathing, running. Or it could represent an email with properties like properties of emails like recipient list, subject, body are the properties. And behaviors like adding attachments and sending. These are the behaviors. Remember that. Put another way, object-oriented programming is an approach for modeling concept modeling object-oriented programming is an approach for modeling concrete real-world things like cars as well as relations between things like companies and employees, students and teacher and so on. OOPS model real-world entities as software objects that have some data associated with them and can perform certain functions. Another common programming paradigm is procedural programming, which structures a program like a recipe in that it provides a set of steps in the form of functions and code blocks that flow sequentially in order to complete a task. The key takeaway is that objects are at the center of object-oriented programming in Python, not only representing the data as in procedural programming, but in the overall structure of the program as well. Define a class in Python. Primitive data structures like numbers, Strings and lists are designed to represent simple piece of information, such as the cost of an apple, the name of a poem, or your favorite colors, respectively. What if you want to represent something more complex? For example, let's say you want to track employees in an organization. You need to store some basic information about each employee, such as their name, age, position, and the year they started working. One way to do this is to represent each employee as a list. Right. Let's go to Jupyter Notebook and I'll show you some example there. Uh, right. We are on, oops, concepts, class 1. This is our first class. So we'll be having 4 classes, I think, on this. So I have splitted this class so that I can give more time on each session. Now, let's say ABC, John is equal to James, John, and age is 34, and he is a captain, and 2265 is the employee code. Sorry, we need this outside the 265. Right. Tyson is Mike Tyson is an employee, and the age is 44, and he is science officer, and the code is 1234. Right. Okay. McCoy is equal to a node McCoy, and the age, we don't have age, and chief medical officer, and the ID is 2277. Right. This is our employees list. There are number of issues with this approach. First, it can make large code files more difficult to manage. With the of reference of John 0, several lines away from where the John list is declared. Will you remember that element with index 0 is the employee's name? And second, it can introduce errors if not every employee has the same number of elements in the list. In the McCoy list, the age is missing, so McCoy's one will return Chief Medical Officer instead of McCoy's age. A great way to make this type of code more manageable and more maintainable is to use classes. Right. Now, classes versus instances. Excuse me. Classes are used to create user-defined data structures. Classes define functions called methods, which identify the behaviors and actions that an object created from the class can perform with its data. In this tutorial, you will create a dog class that stores some information about the characteristics and behaviors that an individual dog can have. A class is a blueprint for how something should be defined. It does not actually contain any data. The dog class specifies that a name and an age are necessary for defining a dog, but it doesn't contain the name or age of any specific dog. While the class is the blueprint, an instance is an object that is built from a class and contains real data. An instance of the dog class is not a blueprint anymore. It's an actual dog with name like Miles, who is 4 year old. Put another way, a class is like a form or questionnaire. An instance is like a form that has been filled out with information. A class is like a form. An instance is like a form that has been filled out with information. Class is a form, instance is a form that has been filled with an information. Just like many people can fill out the same form with their own unique information, many instances can be created from a single class. Next, how to define a class? All class definitions start with the class keyword, which is followed by the name of the class and a row. Any code that is indented below the class definition is considered part of the class body. Here's an example of the class. You can see it on the screen. Class dog is pass. The body of the dog class consists of a single statement. The pass keyword. Pass is often used as a placeholder indicating where code will eventually go. It allows you to run this code without Python throwing an error. Python class names are written in capitalized words, notion by conversion. For example, a class for a specific breed of dog, like the Jack Russell, would be written as Jack Russell in single word. The dog class isn't very interesting right now, so let's spruce it up a bit by defining some properties that all dog objects should have. There are a number of properties that we can choose from, including name, age, coat color, and breed. To keep things simple, we'll just use name and age. The properties that all dog objects must have are defined in a method class underscore underscore int underscore underscore. Every time a new dog object is created, int sets the initial state of the object by assessing the values of the object's properties. That is, int initialize each new instance of the class. You can give int any number of parameters, but the first parameter will always be a variable called self. When a new class instance is created, the instance is automatically passed to the self parameter in int so that new attributes can be defined on the object. Let's update the doc class with an underscore underscore int underscore underscore method that creates dot name and dot age attributes. Let's check out in our Jupyter node. Let's see. This is nothing, so I don't have to run this code, but shown you just for the understanding. Now, will class dog VAF underscore underscore NIT underscore underscore here self comma name comma age is self dot name is equal to name, self dot age is equal to age. Notice that the int method signature is indent 4 spaces. We have 2 here and 2 here. Right. The body of the method is indented by 8 spaces. This indentation is virtually important. It tells Python that the underscore underscore int method belongs to the dog class. Belongs to the dog class. In the body of int, there are 2 statements using the self variable. The self name is name. The name creates an attribute called name and assigns to it the value of the name parameter. The self age creates an attribute called age and assigns to it the value of the age parameter. Attributes created in int are called instance attributes. An instance attribute value is specified to a particular instance of the class. All dog objects have a name and an age, but the values for the name and the age attributes will vary depending on the dog instance. On the other hand, class attributes are attributes that have the same value for all class instances. You can define a class attribute by assigning a value to a variable name outside the int. For example, the dog class has a class attribute called species with the value canis families. Right. Now, here the class dog. What we are doing here is class attribute is species is equal to canis. Right. Class attributes are defined directly beneath the first line of the class name and are indented by 4 spaces. Indented by these 4 spaces. They must always be assigned as initial value when an instance of the class is created. Class attributes are automatically created and assigned to their initial values. Use class attributes to define properties that should have the same value for every class instance. Use instance attributes for properties that vary from one instance to another. Now that we have a dog class, let's create some dogs. Right. Let's insert cell below this. Okay. Now we'll just class dog colon and just we enter pass and just execute this code. Let's see what will happen. This creates a new dog class with no attributes or methods. There are no attributes, there are no methods. Creating a new object for a class is called instinct, instinct, instantiating an object. Instantiating an object. You can instantiate a new dog object by typing the name of a class followed by opening and closing parentheses like dog. So if I want to instantiate dog, so I can instantiate in this way. So execute this. So we have a dog class ready. So what we have created here, this is the way how we can instantiate. You can now have a dog object at, so this is the object address. This funny looking string of letters and numbers is a memory address that indicates where the dog object is stored in your computer's memory. Note that the address you see on your screen will be different. Now instantiate a second dog object. Now one more time we'll instantiate a dog object. So the new dog instant is located at a different memory address. That's because it's an entirely new instance and is completely unique for the first dog object that you instantiate. To see dog way, we will try another example, right? A sorry, A equal to dog, B equal to dog, A equal to B. So let's execute this. The answer is false. A equal to B. Answer is false. In this code, you create two new dog objects and assign them to the variables A and B. When you compare A and B using the equal to operator, the result is false, even though A and B are both instances of the dog class. They represent two distinct objects in memory, right? So they represent two distinct operators in the memory. Classes and instance attributes. Now we'll create a new dog class with a class attribute called species and two instances attribute called name and age. We go back to Jupyter Notebook, and here now we'll create a class dog, and here class attribute species is equal to canis familiaris, right? Now def in self name age. Now self dot name is equal to name. Self dot age is equal to age. To instantiate objects of the dog class, you need to provide values for the name, age. If you don't, then Python rises a type error. Let's see. Let's execute this and let's see what error we will get. Now instantiate a dog class. Alright. So we have a type error. You can see it here. What error we have? Type error int missing two required optional arguments, name and age. Right. To pass arguments in the name and age parameters, put values into parentheses after the class name. After the class name, like buddy is equal to dog. Alright guys, let's add buddy. Buddy is equal to dog buddy, comma 9. Miles is equal to dog miles, comma 4. So I'm defining this and let's execute. This creates two new dog instances, one for a 9-year-old dog named Buddy and one for a 4-year-old dog named Miles. The dog class int method has three parameters. So why are only two arguments passed to it in the example? When you instantiate a dog object, Python creates a new instance and passes it to the first parameter of the int. This specially this removes the self parameter, so you only need to worry about the name and the age parameters. After you create the dog instance, you can access that instance attributes using dot notation, like here how we are going to access buddy dot name. Execute. What do we have? The buddy dot age. What do we have? The 9. Miles dot age. What do we have? Age. Miles dot name. What do we have? Name. Right. You can access class attributes the same way, like buddy dot species. Execute. Right. One of the biggest advantages of using classes to organize data is that instances are guaranteed to have the attributes you expect. All dog instances have .species, .name, and .age attributes, so you can use those attributes with confidence, knowing that they will always return a value. Although the attributes are guaranteed to exist, their values can be changed dynamically, like buddy.age is equal to 10. Execute this. Now buddy.age, what do we have? 10. The age has been changed. Buddy age was 9. Now I have changed it to 10. Right. Now I'll change the miles dot species is equal to Felis silvestris. Execute miles dot species. Execute Felis species. Species has been changed. In this example, we change the .age attribute of the body object to 10. Then we change this .species of attribute to the mice object to Felis, which is a species of cat. That makes Miles a pretty strange dog, but it is valid in Python. The key takeaway here is that custom objects are mutable by default. An object is mutable if it can be altered dynamically. For example, lists and dictionaries are mutable, but strings and tuples are immutable. Remember that. Lists and dictionaries are mutable, strings and tuples are immutable. Let's go to instance methods. Instance methods are functions that are defined inside a class and can only be called from an instance of the class. Just like underscore underscore int underscore underscore, and instance method's first parameter is always self. Right, let's try this code in Jupyter Notebook for instance method. Right, class dog species is equal to is def int init underscore underscore self comma name comma age. Right, now self dot name is equal to name, self dot age is equal to age. Next, Now, instance method is def description is self and return f of self dot name is self dot age years old. Right here, let's another instance method def speak self sound. In return, f self dot name says sound. Right. This dog class has two instances methods. You can check. The one is so instance method we have is dot description and dot speak. So we have created two instances. Description returns a string displaying the name and age of the dog, and the speak has one parameter called sound and returns a string containing the dog's name and the sound of the dog. Now we'll execute this code. So we have an error here. Why we have an error? Instead of that, we need to have a code. Now execute this code. The code has been successfully executed. Now I will try the code like miles is equal to dog miles comma 4. Oh, sorry, miles is equal to dog miles comma 4 years old. This is the age, right? Now miles dot description. What is the miles description? Is we have miles. We have to change it to code so that let's execute. Miles is 4 years old. So what we have is miles. So in instance, what we are saying return of miles is the name. Name is miles. Is we have is and 4. So we have self age years old. Right. Miles dot speak bow wow. Miles speak. Let's say oof oof. Let's execute this. Miles say woof woof. Speak. It's gone to speak. First one was gone to description instance. Right. Let's try another one. Miles speak bow wow. Let's execute this. We have bow wow. In this dog class, description returns a string containing information about the dog instance miles. When writing your own classes, it is good idea to have a method that returns a string containing useful information about an instance of the class. However, dot description isn't the most Pythonic way of doing this. When you create a list object, you can use print to display a string that looks like the list. For example, name is equal to special Dan, David, print, name, execute. Right. This is the way it is. Hope it helps you out. Now, checking your understanding. This is a small assignment which you have to do it on your own. Anyway, I'm going to give you the solution for that. Exercise, create a car class. So yeah, first point, you have to create a car class with two instance attributes. Color, which stores the name of the cars, color as a string. Mileage, which stores the number of miles on the car as an integer. Then instantiate two car objects, a blue car with 15,000 miles and a red car with 35,000 miles, and print out their colors and mileage. Your output should look like this. The blue car has 15,000 miles, the red car has 35,000 miles. Right, hope guys, this is a simple assignment, so you can do it. In my next video, I'll post the solution. If you have any problem, just check the solution, check my next video and look for the solution. Try to do it by yourself. It's better. Try to pressurize your brain. You'll get an ideas and you'll get a confidence. Right guys, all the best for your assignment. See you in next video. Take care. Bye bye.